I think it's time to resume the session, but they are still enjoying coffee break.
Yes.
Amy-san, where are you? I can see you.
Now Jamie sir is available now.
I'm not sure. But next presenter is Jamie-san.
Yes.
I wonder if my voice is
You are audible. You are audible, and
maybe. We are still waiting for more participants to come in. And also, next presenter.
yes, yes.
We can start. Hmm. Oh, wait a moment. I needed to check my email. No message. Anyone? Someone recognize Jamie-san? あれかな違う。ハロー。Oh, so, hello. Yeah. So it's okay to resume the session, or should we wait for a while a bit? I can't hear your voice. I can't hear you. Oh, hello. No voice.
No, we are not audible.
Waiting.
How about now? Can you hear me okay?
Yes, okay.
Yes, yes.
Hello.
The correct button has been pressed and it's all working again.
Is it okay to resume, or it's better to wait for a while?
Maybe just wait one more minute. I think people are coming back from the coffee break just a little bit late.
Okay.
And I'll talk fast for my presentation, but yeah.
No. Actually, there are only two speakers in this session, so you are okay to speak slowly, actually.
Yeah, in the room here, I see backpacks on chairs, but not the people that own the backpacks. So they'll be coming back because they left their backpacks here.
Yeah. So please wait for a moment.
Oh, I haven't actually done it yet. Just give me one sec. I'm just. Oh, okay. Were they using a Mac? No. Okay. Oh, okay. Well, let me. So this it should be. How's it looking? I can't see the first screen. Yeah, it looks okay. Well, at least in the small window. Yep. Yep. All good.
Progress.
Okay, we may start the presentation and get moving along. Cool. Thank you everyone for coming back after the break. Welcome to the second half of the Security Working Group session. My name is Jamie Gillespie. I'm one of the Security Working Group co-chairs. Presentation I'm doing today is on some recent data analysis that I've been doing on SMTP server TLS implementations. So what I'm going to be going through in my presentation is just a review of the importance of SMTP security, the overview of SMTP security options that exist out there, the methodology of the testing that I did, the analysis of the security features that I found and didn't find, and recommendations at the end for things. So the importance of SMTP security, email is integral to our work and personal lives. There is so much that is transmitted over email, including personally identifiable information. We have credit card and financial information. We have our passwords, even though passwords shouldn't be sent by email. We have password recovery links being sent by email. We have videos, we have photos. Everything is being sent by email, whether we like it or not. No matter how many times we can tell users, don't send sensitive things by email, they continue doing that. To prove this, just look at what's in your inbox and your sent folder. So, we have blog posts, how to send sensitive information via email. Things like that doesn't really help with the cause. We sort of have to make sure that we are providing secure email services because there are things like that out there. We also have users that don't fully understand how email works. And that's fine. They're not supposed to. They're regular users. They think that they connect to Gmail in a browser and there's a little padlock or some sort of a security icon that says they're connecting to Gmail securely, so therefore their email is secure. Unfortunately, they don't understand SMTP. We have CEOs asking why SSL Labs doesn't give your website an A+. Nice little graphic there, but there isn't a similar thing for email servers. It's a very difficult process to go through, and it doesn't have that visibility. And, the main reason here is that SMTP server-to-server communication is hidden from even fairly technical users. This is a difficult process to see if your email is going to be secure. When you go to a web page, you can tell if it is encrypted, HTTP or HTTPS. Very straightforward and simple. There is no indication like that to say whether your email from your client to the destination will actually be encrypted along the way or not. So, SMTP server-to-server uses Start TLS. This is a sort of retrofit of using an unencrypted protocol and shoehorning encryption into it. That's fine. Decisions were made. This is the way that things are going through and going forward. This is how communication starts, is that it starts as an unencrypted connection. Port 25, very straightforward and simple. If both parties agree, the connection is then upgraded to using Start TLS. Many connections will work perfectly fine if they do not upgrade properly. That means if there is a man-in-the-middle connection, it is possible that they will interrupt the request to go encrypted, it will fail, and then both parties will fall back and agree on unencrypted communication. Now, how would you feel if you were going to your bank's website or some sort of a sensitive website, and if the HTTPS failed, it just silently fell back to an unencrypted connection and didn't warn you or anything like that? It would be unacceptable in the web browser environment, and yet in email, we are perfectly fine with it. So having a look at the overview of different SMTP security options. Now, these options are for certain types. We're not going to be looking at all security options that exist for SMTP, but you'll see how we go with this. So everything around the encryption side of things, and a little bit of spoofing and phishing. So the first one to look at is called DANE, or DNS-based Authentication of Named Entities, DANE. DANE associates a TLS certificate to a server, and it uses DNS for that association. This is optionally without even the need for certificate authority, meaning that the implementation of DANE allows you to use self-signed certificates. Self-signed certificates are a bad thing for web browsers, as there's no root trust and you don't know who it's being signed from. But DANE is allowing you to actually say specifically which self-signed certificate is allowed and approved, and then that is then to be trusted. It uses DNS through TLS-A records, and it requires DNSSEC to be working properly. Because remember, as discussed yesterday, DNS is an unencrypted protocol, and if you're not using DNSSEC, the records in the middle can be changed. So DANE requires DNSSEC. It's not an optional extra component. You sort of have to have that trust all the way through, all the way back. So the other one that we can look at is MTA-STS. This is trying to do the same thing as DANE, but a little bit differently. MTA-STS enables email providers to declare their ability for TLS, and if they want to enforce TLS. This basically means that you can make MTA-STS tell the other client, don't fall back. I support TLS encryption. Please use TLS encryption. And if somebody in the middle tells you different, ignore them and let's only send encrypted communication. For websites and web servers, HSTS is the protocol being used to enforce TLS encryption for websites. MTA-STS is the same sort of thing. Notice the STS on the end of HSTS, and MTA-STS is the same. Now, it is different to DANE. In addition to a DNS record, DANE publishes the policy on a web server, whereas MTA-STS does not. Requires TLS 1.2 or higher, which is a good thing. And the certificates must actually be signed by a trusted root certificate authority. That's not a huge problem now that we have Let's Encrypt, but it can be with any other trusted root CA as well. You should use DNSSEC for maximum security, but it's not an absolute requirement for MTA-STS. Now, DKIM is a little bit different. DKIM is more for detecting spoofed and forged email addresses. So we're not going to go too deep into looking at DKIM, but basically when an email is sent, it's signed with a private key, and then the receiving can use the public key from a DNS record to verify if it was coming from the appropriate source. This does not help with server-to-server communication, so it's a little bit out of scope. The SPF, or Server Sender Policy Framework, similar to DKIM, works a little bit differently. It's a very simple email validation system to prevent spoofing and phishing as well. It works by verifying that the incoming email is coming from an authorized server. Again, this is using DNS records, just text records here. So therefore, DNSSEC should be used to make sure that SPF has its integrity. Again, this one is more for that spoofing forged emails. It's not helping with server-to-server communication, so we're not focusing on SPF here either. And last but not least, with DKIM and SPF, we then have DMARC. DMARC is the validation system to detect and prevent email spoofing. It sort of extends on SPF and DKIM, so DMARC sort of is an add-on afterwards. And you specify to check the from addresses, how to handle failures, and it includes a reporting mechanism as well. Again, out of scope for that server-to-server communication that I'm trying to focus on here. But they are good things to do, so don't forget about those, but it's just not what I'm talking about. So the methodology of what I was doing here, I was investigating domain names, trying to see the security of their server-to-server communication. So I wrote some very, very poorly written Python code. It does the job, but I am not sharing this code. It is a shame to people who call themselves programmers. But it gets the job done. It automated tasks, so I don't have to be at my computer for hours running the same task with minor modifications. It takes in a list of domain names, queries off all their MX records, finds all MX records for each domain, puts those together, queries DNS for MTA STS. Then it looks to see if there is the MTA STS. It then looks to the website and tries to fetch the policies from the website and comparing the MX records against it to see if MTA STS is correctly set up and not just set up at one point in time. Then doing other queries for TLSA records, DMARC and SPF, because it's always interesting to see if people actually do DMARC and SPF properly. SPF is interesting because there can be a lot of recursion that has to be done, as they can include and refer to and redirect to other records. So yeah, scripting up something to query SPF was fun. Then we write all this out into a whole bunch of different files to allow processing, some of the files for debugging, and some of the files just so that I can grep them very easily. For the actual tools that we then used off the shelf, we have testssl.sh from the website of the same name. This is the tool that actually does similar to Qualys's SSL Labs, but it does it for any server on any port number. So the Qualys SSL Labs, that gives you the little green A+ check mark sort of a thing, that is only for websites. You cannot use that tool to do anything against mail servers. So using a tool like this, we can sort of force it to do something for Start TLS. We can force it to go to port 25 and all the others and do the assessment. It provides output to CSV and JSON, which makes it very easy for analysis. And as a backup, I also use a similar tool called SSL Scan to validate some of the results. If things looked a bit weird from test SSL, I validated with a second tool to make sure that it wasn't just a weird error in the way that one was being handled. And then once I get all of this data, I do some very basic greps using Excel spreadsheets and some custom scripts to difference the files as we go through. So who did I pick on? So I've run this against Australian organizations as well, and then I've added on the NRENs. So we have all of the member organizations of APAN. So we have the primary main full members, we have associate members and affiliate members. In total, I think there was about 18 domains that were chosen from there. For reference against other organizations, I then went to the Australian Stock Exchange and picked up the 100 top companies that are listed on the Australian Stock Exchange. I have done some analysis of other countries, but I find it's easier to pick on my own country as it doesn't make it look like I'm trying to attack someone else's country too much. Because the ASX 100 is the 100 largest publicly traded companies in Australia, I also went to the lowest of the ASX list. So any listed companies with less than $2 million of market cap. So this is like the very bottom 20 companies of the stock exchange. I also went after Australia's top internet service providers. And for a comparison against that, I also looked at top international email providers, such as Google, Microsoft, Yahoo, and similar. So let's get let's rip the Band-Aid off and get the big stuff out of the way first. For APAN member NRENs, we had 18 domains that were chosen from the member list. Most of them are running self-hosting mail servers or hosting through a parent university, depending upon how the NREN is placed in their country or economy. Of the ones that were using external hosting, 4 were using Outlook, and 3 of them were using Google.com. 3 domains have mail servers across 2 providers, some of which were old, dead, and not responding. 3 domains use mail servers that don't support Start TLS, and all the domains used valid certificates. One thing that I didn't mention in here is even though they were using valid certificates, some of them were self-signed, so they were technically valid, but not very valid. And several of them were using expired certificates as well. So that was another interesting thing. When you have SMTP to SMTP communication, expired certificates do not throw up error messages. And it's not something that you see from the client side. So you've got a valid certificate, but it's expired. Like it's working, it does the job, but it can't really be trusted. So yeah, it was very interesting. On the other side of things, SPF, the use of SPF was for pretty much everybody had SPF turned on and running. It was a split between using soft fail or fail, so, you know, pretty good. One SPF record didn't specify an action, so it actually defaults to pass. So even though one of the 18 has SPF, it's not doing anything. For DMARC, 9 of the 18 had no DMARC policy created at all. 4 with the DMARC policy were actually set to none. So they went through the work of creating a DMARC policy, but the action was set to none to do nothing. One of the ones that was setting to none actually was a broken DMARC policy. And that's an interesting thing that happens about 5% of the time, is that people create these policies and they create them in a broken fashion so that they actually won't be obeyed by anybody looking at them. So this one had a P equals space none, whereas it's supposed to be P equals none. So yeah, formatting was wrong. 3 domains had the DMARC policy set to quarantine, which is good. And 2 domains had a DMARC policy set to reject, which is even better. 6 of the 9 domains that had DMARC policies also had reporting configured. So of the ones that actually had policies created, 2/3 were using email reporting so that they could actually see what was going on. So that was a good thing too. And that's where it sort of ends for the good stuff. No domains had MTA STS implemented, and no domains had TLSA records for Dane either. 3 domains didn't actually even support Start TLS. So a small correction, my wording was a bit wrong previously. Of the ones that had valid certificates, those are the ones that support Start TLS. So 3 NREN domains don't even support encrypted email. 1 domain had 3 mail servers listed, all with equal MX weighting, and the third one was unreachable. Now, that could be point in time. I did test it over 2 different days, but it was unreachable for 2 days in a row. All domains supported TLS 1.0 still. Comparing this to the large companies in Australia, I looked at 95 domains of the ASX 100. There was some duplication where one company owns other companies. 100% were using SPF. One had a null record. It was missing TXT and other broken things. For DMARC, 9 domains out of 95 had no DMARC policy, but 33 of them had a policy set to none. This ratio and percentage is roughly what we saw with the NREN APAN members as well. If we look at MTA STS, only 1 domain had MTA STS created. Again, roughly what we saw with APAN members. No domains had TLSA records, and 1 pair was actually using self-signed certs. We did see a little bit more on the self-signed certs for NRENs. For the very low end of publicly listed companies, so $2 million of market cap is actually not a lot in Australia, so they are smaller companies or younger companies. There were 13 domains in this category. Most of them were outsourcing their mail, most of them using Outlook and Google. Again, a lot of SPF, 100% coverage of SPF. This is a standard thing that people are realizing they need to help, but not completely stop phishing and spoofing. One of the interesting broken records that we saw here is down at the bottom. I've added some coloring to highlight what was going on. They took their TXT record, and it looks like someone was editing it manually, maybe using VI, and they weren't used to VI commands. And they actually took a copy and paste of another TXT record and jammed it into the middle of their SPF record, obviously breaking both TXT records. So if it was just the green text, then that would be a valid SPF record. And the red text in the middle, if that was on its own, that is a domain verification for Atlassian's products. So yeah, that was an interesting find. Only 2 domains had a DMARC policy. None had MTA STS. None of them had TLSA records for Dane. Again, pretty similar to the other ones. For the large ISPs in Australia, I chose 20 of them. I tried to avoid parent and child ISPs as they probably use similar infrastructure. Most of them, and these were for the ISPs themselves that we're looking at here. Most are running their own mail servers. A few were outsourcing to Outlook, Mimecast, and Google. SPF, 1 domain is missing an SPF record completely, so that's an oddity there. DMARC, 11 of them didn't have any at all, which is on par. None of them had MTA STS. None of them had Dane TLSA records either. And then if we look at top international email providers, these are the companies that do email as their job. This is their primary function. This is their reason for being. This is where they make their money. Some examples of what they are up there. I tried to be a little bit international by picking up like some Yandex and that and GMX, but I was aiming for the really big email providers. All of them are running their own mail servers, of course, because that's their jobs. Only 1 of them was missing an SPF record. 2 domains had a question mark all, which is almost the same as having no record at all. And the rest is split between fail and soft fail. So we're actually seeing a percentage decrease in SPF records by looking at these email providers. For DMARC, we had pretty good coverage for this. Only 2 of them didn't have a DMARC policy at all. 7 had the policy and set to none. This could be difference between using the domain for their customers and the domain for their employees. For example, with Google, the customers use gmail.com, whereas the employees use google.com. Google.com has a reject policy, but gmail.com has it set to none. So there could be some difference there. Now we get to the, we finally have numbers at the bottom. 8 of these domains had MTA STS configured. So we finally see some companies using it. And 4 domains were using TLSA records for Dane. Still quite small compared to how many, what was it, 17 domains in total, and 4 of them were using TLSA records. We did see a whole bunch of weird oddities, expired certificates. I didn't list the NRENs here as well, but we did see about 3 NRENs using expired certificates. 2 Australian ISPs were using anonymous cipher suites, which is basically encryption that's like not encryption. Like it doesn't require any authentication back and forth for the encryption to happen. So could be man in the middle super easily. If we look at some of the really old encryption technologies, there was one of them still running SSL version 2. I manually tested this. It was really running SSL version 2, and several of them are running SSL version 3. And of these ones, they are some big ones. MessageLabs.com is a big email protection company. pphosted.com is big for email. Telstra.net is a major internet service provider in Australia. And Yandex is obviously a large mail provider as well. TLS1 was still available for many big internet email providers. A few of them were supporting only TLS 1.2, which was really good to see. And the ones supporting TLS 1.2 also supported TLS 1.3. This is basically like standard and mandatory for companies to be doing good website security. And it's strange to see such few internet providers doing this for email security as well. It's also noted that Outlook.com, Barracuda, pp-hosted, and some others are not even supporting TLS 1.3 yet. TLS 1.3 has been out for a few years in websites, and email products should be using this as well. So recommendations for this. First off, test your own servers. I'm not naming names for too many things here, so get out, test your own servers, and fix your own servers. Don't just test them. There are tools to use. Test SSL, SSL scan, those were the ones that I was using. There are some websites that will do some scanning of your email for you in different fashions. It's hard to use them for many domains, but if you're testing just your own domain, they're actually quite easy. Internet.nl, the Netherlands has a great website. aucheck.com.au, relatively new, but using source code from internet.nl. So there's a few different options for you to do. Also make sure that you're checking DNSSEC signing on your domain. There's a couple tools that you can use here, a program called Delve, as well as just doing some manual digging that you can do as well. Also, make sure that you are deploying SPF, DKIM, and DMARC. These are great. They are not difficult to do. There are website tools to help you do it. And depending upon how you're hosting your DNS, they may actually have easy graphical web-based tools to do it as well. Set up Dane if you haven't done DNSSEC. Set up Dane if you have done DNSSEC. And if you haven't done DNSSEC, go and use MTA STS in the meantime, and then go back and make sure you spend time on DNSSEC if you can as well. And of course, for other sorts of man-in-the-middle attacks, don't forget that BGP hijacking is still a problem. It does allow people to hijack things in the middle, and BGP hijacking can hijack all of your email communication as well. So look into RPKI. Which is sort of APAN's business. So I sort of have to mention RPKI in almost every presentation, or my boss will mention it to me at times. That's the end of my presentation. Does anyone have any questions on the information that I collected and presented? I went through it a little bit quickly. I will get the slides put up onto the Hoover system as well today.
if we configure all this in our mailing system, is there any compatibility issue?
Yeah, so question for those on Zoom is, if we configure all of this for email systems, is there compatibility issues? For SPF, DMARC, and DKIM, and Dane and that, there is not compatibility issues for those. If you're looking at SMTP, if you configure everything properly with MTA and Dane and things like that, they will talk to a client that supports it and enforce encryption. And for ones that don't talk and don't understand it, they will still fall back to unencrypted. But with MTA, STS, and Dane, if the other client understands it, it basically forces it to be encrypted. So it's a way of checking with the client and saying, hey, I really can do encryption, and don't let anybody in the middle tell you different. Whereas if you don't support that, if you just do the good TLS on the other side, it can fall back to unencrypted. So there is always that fallback if the client doesn't understand. But for reasonable clients that are out there, which most of them are reasonable, they will go up and they will forcefully do encryption. Exactly. Yeah. So there really isn't a problem. It's a good question. I've had this even within APNIC as well. When we started on this project and everything, they said, oh, should we turn off TLS 1.0? Because if we get another server that only uses 1.0 and we turn it off, then it will fall back to unencrypted. But TLS 1.0 is deprecated. It is weak. It can be broken. If that's the only thing they can use, it might as well fall back to unencrypted. We have to raise the standards, and we have to make sure that we are providing true secure email services and not just a false sense of security. That said, I'd probably do TLS 1.2 and 1.3. 1.2 is still secure, but anything lower than 1.2, turn it off. Yep. Cool. Excellent. If anybody does think of any questions, I'm easy to spot through the rest of the day. Oh, wait, we do have one more question. Hang on one sec.
So what about other global website? They had any open source SL scanning method or so alternative solutions for that?
The AU check, or which websites was it?
Yeah, you mentioned that the OU domain, they have a SSL scan methods. So
The OU domain?
Yes. The OU, OU, AU, sorry.
Oh, yeah. aucheck.com.au. It doesn't just check Australian sites.
Okay.
It will check anything. And the internet.nl from the Netherlands,
yes,
it will check anything.
It's globally available.
It's globally. Yeah. They're providing it for their citizens.
Okay.
But they're not restricting who they test against. So you can use it for your own companies as well. And if for any reason they change and they do restrict it, or they won't test your specific top-level domain,
okay,
the tools that I mentioned, they're just Linux tools. You can install them as packages like apt-get install sort of a thing, test SSL and SSL scan, and you can just run them from the command line.
Come on.
The problem with doing the scanning yourself, you need to make sure that you're scanning from an IP address that is not classed as a home IP address. If the scanning is done from a home IP address, some mail servers will have filtering that says, you're not supposed to be sending me email, so I'm not going to do a connection to you. So if you're scanning your own mail servers, maybe do it from your university or company network so that it's a more trusted connection to it. But yeah, that was one of the problems. I had to make sure that I did my scanning through the company network, through APNIC's network, which was classed as a trusted server network, not a home dial-up or home internet connection network. Yep.
Okay, thank you.
No worries. Cool. Okay.
Excuse me.
Yep.
May I have one short question?
Yeah, sure.
How can I say? Providing MTA, STS, or then providing the record is maybe easier, but supporting to supporting MT STS is more difficult for open source software such as Postfix, EXIM, QML. I don't know how to read these record and properly handle connections is much more difficult and not supported officially, I think. So are there any comprehensive resources about both sides? How can I say? I don't remember the word, but
Yeah, no, there are some good resources.
Yes, client side and server side, both sides should be implemented to properly deploy that. But I think client side is more difficult to consume the record and properly handle connection. I don't have. I need more implementation to actually deploy this technology, I think, and it is not readily available, I think.
Yeah, no, there's some good tools and guides. Cloudflare has actually done some, even though it's not really their area, they do have some good information. There's another company website I use a lot, MX Toolbox. It's not a sponsorship, it's just one that I use quite a lot. They have good tools for testing and implementation to make sure that what you're doing is correct. And, all of these tools allow you to create your policies where you don't block first. So you can put in the policy and then test it. Make sure that everything is working fine, that you didn't put a space somewhere in by accident. Make sure it's good. Then you can move it up one level to sort of monitoring. And it's still not blocking by default, but you can monitor, make sure the email reports are coming to the right place, that you're analyzing them, using the tools to do the report analyzing and that as well. And then you can move it up to a more blocking level. So for any of those, even back down to SPF, which is been around longer, and as we saw, most people using it, there are tools to help you, bring it up and make sure that you're doing it correctly. A lot of people will put in the initial record saying none or, soft fail, and they'll just leave it at that. And the record is not actually doing the level of protection that they may think that it is. They may think we have SPF, so we're fine, but the SPF policy says do nothing. So yeah, it's a tricky thing. And what I've also seen from some personal experience is if you're getting a security review or an audit done, they don't go very deep. They say, do you use SPF? You say, yes, we have an SPF record. And that's all they ask. They don't ask, are you enforcing it? Are you at risk? So but yeah, it's not too hard to implement. Probably the hardest one is when you're having to deal with SSL certificates and making sure that they are rolling over and changing. As I saw, expired SSL certificates are easy to happen when you don't get warnings and error messages. If your website had an expired SSL certificate, your users would tell you very quickly. But an expired SSL certificate on a mail server, unless you have a monitoring program running, you're not going to notice that. So, probably the other good recommendation is make sure that you are monitoring all of your systems and not just monitoring for uptime, but if you're installing a certificate, monitor that certificate. Make sure it's the same one, make sure it's in date. And these tools, the Test SSL and SSL Scan, they will check for expired certificates as well. So you could even run those on a bit of a scheduled cron job, maybe once a week. If you see something saying expires in less than 30 days, send an email alert, and you can then be notified in advance and use these as monitoring tools for your systems. Out of curiosity, has anybody here used the SSL Labs website, the Qualys site, to get a letter code for your website before? No, it's another interesting one. A lot of people use that to check the websites. So there are these tools out there. And the tools I mentioned are not just mail server checking tools. You can use those to check your websites as well for expired web certificates. So yeah, they're very useful things. With a little bit of scripting, you can have some very powerful monitoring of your public facing systems. Cool. Okay. I'll pass on the next presentation. Thank you.
Okay, so please prepare Rakesh-san for your
Yes.
presentation.
Yes, yes. Can I share my screen?
Not yet. Yes, okay. But it is okay.
Is this visible?
Yes,
Yes.
please go ahead.
Thank you. So, good morning, and I'm Dr. Rakesh and co-chair of this session also. I'm an associate professor at Indian Institute of Information Technology, Jabalpur, India. And today's I will discuss about the behavior model for live detection of apps-based attack. Since we all know that in the current scenario, this apps-based attack is really challenging for all of us. And as a researcher, I have done the case analysis and do the performance analysis, how we can protect this lively through the intruder apps-based attack. So in today's agenda, first I will describe the introductions. Then we have proposed one algorithm, that is application-based behavior model analysis. That behavior model analysis can able to detect the apps-based attack and also the protect such type of the attack that is on regular basis you people are observing in your phones, smartphones. So we will also provide the details about the attack model, intrusion detection system. Then that intrusion detection system is based on some mathematical modeling. And finally, I will do some result analysis what we did in our lab. And finally, we will highlight the impact and applications. So, since we know that in last decade, the smartphones is increases and initially the network is simple networks. Now these days the network is converted as a ultra dense network due to the use of smartphones and different types of applications. The user densification is very high. And after the online shopping, net banking, healthcare monitoring, online educations, this densifications is increases extensively. So that is the advantage of technology, no doubt. But at the same time, they came in the front of us with the numerous challenges, and that challenges is directly related with our securities vulnerabilities. So we know that we in the daily life we are facing this phishing attack, spyware attacks, botnet attacks, malware attacks, and now currently the apps-based attack. So in our country, there is a one apps that was the very popular for this apps-based attack. And that attack was so popular that is the case studies for all the researchers to how we can overcome this apps-based attack. So on the basis of real-time challenges, we have studied and analyzed this attack in our case study. Moreover, we know that vulnerabilities include invalid authorizations, compromise your authenticity, consolidity, and they are also not only directly related with your financial and other things. Now these days are very challenging. Is related with the social attack, and this social attack is directly is challenges for life threats of all the clients. So this huge case study is very important as a researcher who is doing the research in security aspects. Why this is challenging? Because these days we know that in a lot of types of gaming, and gaming is directly related to the school kids and the school going students. So that is more vulnerable and the real challenges for all the researchers community. Because the third party applications marketing one of the major threats, where interested application can be installed by the users. And we know that either we are aware of these type of attacks, but when you are going to install any types of apps, you will give the permissions and allow such type of apps during the any games or any education based apps. They will produce the security influences in data breach. So this is the introductions of this. Here, through this architecture, you can analyze this attack is since this is the background of let us assume that you are using your apps networking through either by base stations, either by Wi-Fi hotspot, either by relays, or different types of network. You are able to access the network. And this is, let us assume that this is your smartphones with valid applications. So let us assume that you have installed 7 valid applications, right? A1, A2, A3, A4, A5, A6, and A7. Or that application might be n numbers of application like this, right? So that this smartphones with the valid applications. But just the previous presentations, if your network is not updated, not secure, then there is the chance to the different types of apps will install through link, through these days PDF files, through mails. So intruder apps can also install during the any type of if you want to play some games, or you are just click on any you have received the mail like your meeting is going on, schedule is on this that day, and you just click that link, and suddenly one app has installed. And what are the scenario challenges for researchers? That apps is not visible, that performs as a invisible in nature. So that apps is hidden in your mobile phones, right? So that is the intruder apps under hidden mode, right? So now initially you have installed let us say that 7 apps. Now this apps is also installed on your phone, and that is not countable because that is not visualized by the any users, right? So now this attack, this intruder app under hidden node will performs like they will perform in a different manner, because this type of attack is basically it's compromising type of nature. They operate 24/7 into 365 operations. They always capture the informations, what you are typing, what you are getting, which type of OTP are you receiving. So that type of attack is very challenging for in the real time scenario. So attack state to detection state. So we have proposed one states, that is the if once your apps is hidden, how we can protect them. Because in a lot of cases we have observed, and you people also observed, that is directly related to to the kids or human life threats. by using of social attack by the intruder, right? So this smartphone under app-based attack detections. So how we can detect? I will explain, one by one. So let us assume that we have proposed one, algorithm or proposal that is known as AMBA, application-based behavior model analysis system model. So what we did in this model, the fundamental of the system model consists of different types of end users and application-based scenario. Some users might be looking for video applications. Some users might be voice applications. Some users use only the text applications based informations, right? So these informations, no doubt, they are connected through different 5G, 6G networks or Wi-Fi hotspot or device-wise communications networks, right? So the what we did in this proposals, the end user have the different smartphones and they are using a different number of applications. Let us assume that n number of applications they are using, right? And A1, A2 like that, A1, A2, AN applications are there. And let us assume that in first case, all the applications are valid applications like Facebook, WhatsApp, and other apps is it's valid applications. Let us assume that. The intruder is considered to be present in a scenario having an interest to obtain the confidential information of the valid user from the smartphones, right? So what they will do, the intruder implies advertisement assets add on their applications to breach their smartphones, right? The intruder is assumed to have a keen watch on actions of the valid user on the smartphones, like which type of website or which types of apps they are looking for. So they are closely monitoring, let us assume that they are looking for, some restaurant case study. Someone is doing, daily life is a game, is a their choice. So intruder is firstly trace the behavior of that users. Once they found their behavior, on the basis of that behavior, they will send the link or link to that apps based link. And after that applications, that link has been clicked by that users, and that is application. Let us assume that initially the applications is A1, A2, A3 types of apps is there. So after currently I have the smartphones and currently 10 applications there, right? But on the behavior of behavior modeling, they understood what is my the choice of apps is in current last week or next last week. So on the basis of that my prediction model, I will click that types of apps or looking for that type of apps, and once I will click that types of social link, that is apps will install. But in visualization mode, we still I can able to see only 7 apps. But what happened if initially AN application is there, then finally after that AN plus 1 application has been installed, but that is not in visual mode. So this is the attack model of my proposal. So we know that different types of network and user is might be using healthcare applications, IoT applications, and device-to-device communications based applications. And what happened? Let us assume that this intruder, what they do, intruder after your behavior modeling, they will send the mail, searching browser, and other application link to the Play Store. Like let us assume that you are looking for some purchasing, like Amazon website. Through the phishing attack, they will also produce the same page reflections, and we are as a general client, they are so hurry, they are not, and that is also not possible. They will validate and everything, like all the phishing based website, also the HTTPS based secure based. So it's very difficult to find out which is the original, which is the phishing based page. So through the mail, searching, browser, and other application linked to the Play Store. Now, after this, once you will click them, here you are able to see the other apps. The 6 is valid apps, but this one is the hidden activated hidden applications is there. So might be they are watching your through the camera, watching the content. They also reviewed your WhatsApp chat and other things. So default, we every times we observe that there's a lot of conditions to before the installation, but more than 50% users doesn't look what are the permission they are required. We only see yes, yes, yes like that. So default yes permissions give the chance to they will install in your system, and once they will install, they are spreading or assessing the settings and other apps also. So initially all the valid users, those are valid in nature, but after this hidden applications, they produce as a vulnerable in nature, and it's very difficult to to secure your data in your smartphones, right? So this type of this is the entire flow of this vulnerable application based attack. So this is the attack model of our proposed work, right? Next is so I already explained this. So the attack modeling provides the framework of the possible social application based attack. Secondly, the intruder makes use of one or more vulnerable applications to initialize the attack and the executions. The intruder provides the installation link on other install application of the cell. And after I already told by the default, yes, we are giving the chance to this type of attacks can be installed on your phone. So after they once they install, they will play like anything. So what they do, so so once they installed, they will fetch the information, send to the other client, and that is if you think once, that is a very challenging and very important task, how we can secure that types of social attack. So and Pegasus is one type of software that was really challenging, and really a lot of news has been distributed in the entire country, or maybe many apps. I just giving one name. So that is very challenging and very important for how we can protect that type of attack. So we have provide one intrusion detection model for IDS model for this type of attack can be protected. So this is under prototype modeling. And what we did in this case, so here application process, this application process, the red in color, that means that is vulnerable in nature. And here is a application monitoring process. So and we have done one analysis that is known as thermal numerical analysis or thermal pattern analysis. So what is the thermal pattern or numerical analysis is since I will explain in detail. So on the basis of thermal pattern analysis or numerical analysis, we are able to detect the attack and followed by give the alarm also, right? So once the alarm has been produced, you will deactivate your phone is automatically deactivated from the cellular service and internet accessibility, the first case. And after that, in second iterations, you can remove that apps so that you can secure by such type of attack. So how this can be possible? Since we know that if let us assume that 7 apps is currently valid valid apps installed in your phone. So we have done the 3D modeling thermal pattern analysis. So let us assume that we have divided in different colors of that battery lifetime and battery computation computation time, battery lifetime. So what happened, what we have observed in real-time analysis, uh, if one day, we have done the analysis for 1 day, 1 hour, 1 day, 7 day, and 30 days case studies. So let us assume that in 1 day, first 1 day, let us assume that there is no any intruder apps or hidden apps is installed in your phone. Then we have done the analysis how much battery lifetime is required for same types of we have also done minute case studies. Let us assume that 30 minutes we will use WhatsApp, 30 minutes YouTube, 30 minutes like that. So on the same proportional, when the hidden node is available on your phone, the same case study 30 minutes for all 30 minutes for all the applications. And also we have done the same explode that case study for 1 hour, 1 day, 1 week, and 30 days, 1 month, right? So what we have observed, there is a clear 3D thermal pattern analysis will predict yes, with attack and without attack, there is a thermal pattern difference between both the case studies, either for 1 hour or 30 days. And then we have passed through there is a the delta T, that is the threshold. Let us assume that initially for valid applications T is the threshold value, but after this hidden node is there in your phone that produce the plus delta T changed. So once the information T plus delta T, then there is a one apps based alarm detection system is there. If unwanted and exponentially your battery power is consumption is higher, or thermal pattern difference is slightly exponential, then that alarm will be produced. And since that time your that is very important information, because that is directly related with your social attack. So what we have done in second phase, once they have produced the alarm, in second phase your net connection is already deactivated, because once your internet will be deactivated, the third person who is watching your informations from the other side, you will somehow safe from that side. So this is the overall intrusion detection model from our lab. After this, this intrusion detection model, what I have discussed here, the same is discussed here. This is the theoretical part. So in first phase they will produce the alarm, and second phase automatically deactivated from the internet, so that you will save by the social attack, right? So in next case, we have done the mathematical modeling. So the thermal pattern analysis is the the 3D modeling based observation, but in the background there is the data rate, capacity, and battery lifetime, energy efficiency, the four important parameters we have analyzed. So based on the demand applications and the resource allocation of the corresponding application, the total estimated power we have calculated. And after that, we have also considered the noise power, channel coefficient. You can observe here, this is the power is required. Omega is the noise power, H is the channel coefficient, beta is the allocated bandwidth, gamma is the data rate of that one. And once we have calculated the power of the user, then we can calculate the SINR. And once we calculate the SNR, we can able to calculate the data rate, the corresponding total data rate of different applications. Let us assume that some users are using video applications, some users are using voice applications. So we also characterized with this mathematical modeling, different data rate is required for different case studies. Right. Secondly, the first is data rate and power. Second one is we have calculated the battery lifetime. So this battery lifetime can be calculated is the total battery capacity. That depends on your if you have the mobile phone, then you know that some mobile phones have the 4000 mAh, someone 4500 mAh, someone has 5000 mAh. So different capacity. On the basis of that phone, we have considered to general Android phone and Apple based phones case study. So that and both the nature of phones, our case study is equally worked same. So battery lifetime we can calculate through this. At the same time, we have also the last one, third parameter we have analyzed. That is the energy efficiency, right? So on these three parameters, that means the data rate, that means based on the application you have demanded, how much your battery lifetime, and energy efficiency. These three parameters is the core parameter to analyze the this apps-based attack on the mobile phones, right? So this these three parameters is critical parameter to analyze the analysis, right? Now, in next phase, we will do the result analysis. In this case, so here in the first case, our proposal is already I told Amba using Wi-Fi. So one things I have forgotten about the mentioning this. We have also analyzed this case study through different type of networks. Let us assume that one user is using general cellular communications, 4G and 5G. Some users are using Wi-Fi, right? Because we know that why we have done the different case study, because if you communicating through base stations, then no doubt your battery lifetime will be lower as compared to Wi-Fi communication, because Wi-Fi is nearby hotspot, so path loss is minimum as compared to if you communicate with the base stations. So we have also considered that case. Either you are communicating through base stations or either you are communicating through Wi-Fi and hotspot. Right. So in this case, we have done the 3D modeling analysis. So this here we are able to see using Wi-Fi for 1 hour duration without attack, and here using Wi-Fi for with attack. So clearly you can able to visualize this this value y. The x-axis power requirement is 92, but here is with attack sorry, x value is 89, and for 1 hours they can give the 94.97. So peak, you just compare this peak, that will be increased, and reddish portion is highly battery required, or you also observe that if some hidden apps is available in your phone is battery lifetime decreases and hit somehow. So that is the general without the case study thinking, but here is also proof of this. So excess of threshold with attack is there, right? So that is the one provision through 3D modeling thermal pattern analysis we can able to detect. Secondly, same thing we have done for 1 day. So we are able to see here 0. Less than 0.2, but here is peak is approximately 0.2. Here is 230 power ampere hour is required here, and power ampere hour is required at 280. So so clearly we can analyze with this pattern analysis, thermal pattern analysis. With attack, the power is required high and battery lifetime is also low. So once this type of phenomena will suddenly appear in your mobile phone, our algorithm will provide the alarm something is wrong is going on your smartphone. So you will receive the alarm. At the same time, next iteration they will also protect from the internet, right? So this is the real time the case studies for this is for 1 week durations. We have compared for 1 week durations, and without attack, and with attack also. So again, you are able to see for 1 week, if we have considered 5 apps, 6 apps condition for the same time, same nature of phone, then that is a drastical difference. So here X or 75. So you can able to see the power case or thermal pattern is clearly differentiate between without attack and with attack case studies. Due to the time limit, I will conclude very soon. Since this is the thermal pattern analysis, at the same time, we have also provided the data what we have observed in real time case studies. That is real time analysis for different applications using mobile data. So we, as you able to see here, we have done the durations of 1 hour, 1 day, 1 week, and 1 month. And we have considered the valid application WhatsApp, Facebook, YouTube, Chrome, Gmail, Amazon, or into the applications those has been that apps has developed by our core team, that is the UG students, and that is random in nature, and we are able to see average data is required for 1 hour. Average battery lifetime is required for 1 hour. Average power consumption is required. So you are able to see here in student applications case studies, average power consumption is very high in all the cases, very high. So once that all the data and training on the all that basis on the basis of training, this data is passed through the IDS system. Since this value is very high, and that initially if you calculate, add all the 6, so let us say that 100 milliampere is required, right? But suddenly if the intruder will add, then your T is increased by delta T. So on the basis of your mathematical modeling, on the basis of thermal pattern analysis, will provide the alarm, and we are able to detect the such type of hidden node apps-based attack, right? Similarly, in the same case, we can able to see here apps-based energy efficiency. So what we observed that we have compared 1 hour with attack, without attack, 1 day, and for 1 week. So the next slide we will conclude here. So overall, so in figure 9, we are able to observe this overall app-based complexity will also reduce. See here. So with attack for 1 day is here, near about complexity is very higher. But with attack for without attack for 1 day is very lower. And what we have observed, complexity increase for 1 hour is more than complexity increase for 1 day. So if any hidden nodes is available in your phone, so with the complexity analysis, we can also able to detect that attack. So 1 day or 1 week, such type of power difference is required. If any hidden apps is installed in your system, right? So similarly, in the same figure 10 is also telling the same thing. Last result, we have calculated the average apps-based battery lifetime. So we can able to see without attack is very higher, right? 35 or 32 hours is will give the backup of your mobile phone. But once the attack will be appeared at the same time, they will only give the 22 hours. So sometimes we feel maybe my battery is not working, but we did the case study for the same conditions. The battery is in the same condition, apps is running the same conditions, network is same conditions. Then we have analyzed and conclude this battery lifetime complexity is also complexity very high in the case of apps-based attack. Battery lifetime is low in the case of when the hidden node is present in your system. So finally, I can conclude here. So behavior model for live detection of ASPAT attack mechanism involves the user and attack wherein the attack includes the installation of vulnerable application on the cell phones, while the incorporating activation under hidden mode. Right, you have installed that apps, but apps is performing unbehavior nature, random based nature, without you are able to see. The detection model performs the monitoring of invalid application installation by using comparative thermal pattern analysis, and based on the analysis of the behavior pattern, we can able to judge is there hidden apps is available in your phone or not. And to prove this, to analyze this, the complexity and battery lifetime is the important characteristics to analyze this type of attack. So our proposal is can perform and can provide the solutions in upcoming days. That is really challenging for all the researchers, because that apps-based attack is directly related to live threat and social attack. So this is and this case study already published in Transactions, IEEE Transactions. So please refer that one. And now we know that security to the net banking, let us assume that now these days in our country, phishing attack is a common thing. So security to the net banking application, GPay, MPay, etc. UPI payment is very vulnerable if any hidden node is present in your mobile phones. Security to the service specified applications such as healthcare, Healthify, book reading applications, Adobe PD, that is also very challenging. Security to online shopping applications, Amazon, Myntra, Flipkart. Security to share market applications, Upstock, Grow. Security to the defense-based applications. Security to the social networking, Facebook, Instagram. Reduction in the cybercrime relates to the confidentiality of the data in the mobile application. That means our proposal is really a good platform if they will in real time scenario, if we will deploy this, so they will provide good solutions. Last one, this is the some references. So now here I conclude my proposal, and I'm really thankful to the chair. And please, any questions, please let me know so that I can try my level best to answer. I'm audible, Kisara?
Thank you very much for your presentation. And any questions or comments from participants? Do you have any? I have. Are there? How can I say? There are some reference papers before the slide. This slide.
Yes.
Is this the, how can I say, the summary of this paper? Is this your presentation this time?
Yes, so that paper is here.
Have you already published?
Yes, yes.
Oh, really?
Yes, sir. So I'm just no, I have mentioned in second number of slide here. That is, and also patented. So here, so this one, behavior model for live detection of apps-based attack, and that is in IEEE transition on computational social system. And
do you have any prototype implementation?
Yes. So, Kisara, we have developed the apps. Those that apps is performed as a intruder behavior, random in nature, and also that apps is nature to hide, hiding in nature. So once they have installed through any link, they are performing as it is, because we have done this the real-time case studies in our lab. for 1 hour, 1 day, 1 week, and 30 days, right? So what we did, the same, same networks for same for with attack and without attack, both the case studies. And also we have applied the same types of applications like video application for sometimes the same for both without attack and with attack. And after the modeling, this thermal pattern analysis, so what we see, there's a pattern, once if the battery lifetime is higher, then color is highly dense as compared to without attack. So once they will, on the basis of this dense pattern, they will produce alarm, right? So the user, since you are a user, you don't know, currently morning 8 a.m. there's a 5 apps you are using, but currently suddenly by after 8:30 you are accessing any mails, and through that mails might be there's a chance one app will install on your system, right? So but that nodes is not able to, you are not able to visualize, because on your front of panel of your mobile, you are only see again 7 apps is only there, but that nodes is already now installed in your system, and that is behaving on the hidden as a behavior as a hidden nodes. And that is they are capturing the image data, right? So what happened, they will activate in broadcasting manner. So the battery lifetime pattern is changed as compared to 8 a.m. before or 8:30 after. So these patterns can be analyzed through this thermal pattern, right? Thermal pattern now, the region of this green is lower and reddish is higher. So our apps is detect that pattern. Something is wrong is going on phone, so they will produce alarm. So you have get the information, some other apps might be installed on system, so you are protected from such type of attacks. So that is really beneficial for the future scenario, if some users are not able to find out that apps is valid or not valid. So what happened currently in India or other country also, the teenagers, students is very motivated about the game apps. So they are installing the unauthorized game apps frequently. So sometimes that apps, unauthorized apps, is not able to visualize, and they can provide the data, capture the data, and provide the third party. So that is the very challenging task.
Okay, thank you very much. Any other questions or comment? So I think it's almost the ending time of this second session. Thank you very much for both co-chairs to have a presentation this time. And thank you very much for coming to this, for audience. Thank you very much for coming. I'm sorry I didn't physically attend this time, but the next APAN meeting in Thailand, 57th, I want to attend the meeting physically. And as always, we are seeking for security-related presentations for every APAN meeting. So if you or your colleagues interested in visiting APAN, please encourage them to submit some proposal to APAN or security working group. So anything, Jamie-san, anything you want to comment? Is he? No, he's not here. I'm not sure. Anyway, thank you very much. I'd like to conclude this session. Thank you very much, and enjoy your lunch. Thank you very much.
Thank you.
あれおー ん
Thank you.
Thank you very
Bye
much.
bye, Kasera. Bye.
Thank you very much. See you next time.
Yeah. Thank you.
It, it's okay to disconnect.